All right, let's solve this triangular load. Now, we solved one last time, but if you guys remember, the orientation was this way, right? Now we're solving one with the orientation pretty much inversely and opposite. Now, it's not no need to get scared. The only I mean, what's the same? Let's figure out what the same is. The same is that it's a triangular load. So the magnitude of the force is still, let's get it, 1/2 base times height. So that's 1/2 times 14 meters, which is how long the beam is, times the height, right? This 200. So let's see what I get. 1/2 14 times 200. I'm getting 1400 kilonewtons. Gonna erase this math here. If it works, I'll just use the erase. So I got 1400, right? But now, where's the location of this, right? So let me move this. I'm gonna use blue. Give my arrow. This is my 1400 kilonewtons. So last time it was 1/3 away. It's 1/3 away from wherever the the max of where it's peaking at in terms of the load. So if it's about B, it'd be 1/3, 1/3 from this point, right? But if we're looking at it from this way, looking at it from that, it'd be 2/3 away. So over here, the location would be 1/3 away, and over here it'd be 2/3 away. And it's gonna give you the same value. So let's see, let's try it. 2/3 away, and it's 14 meters long. It's gonna give me a value from this point, from this value here, right? So I'm going to use green. From here, 2/3 away is giving me, this is 7, 8, it's giving, I'm calculating 9.33, right? So from here, 9.33, right? This is my 2/3. From this point, I could do 1/3 times 14. That's giving me 4.66. I'm going to do this one in blue. So from this point, 4.66. And essentially, if you do the math, 9.33 plus 4.66, it's giving me 14. It's 14. Now, what does that mean? It's just about how you look at it. From this way, it's 4.66, and from this way, it's 9.33. But they're the exact location, right? The exact location. So let's do our point load. It's going to be 1400 kilonewtons. Now, it all matters where you want to take the sum of the moment at. So if I take the sum of the moment about A, which I preferably like to do, I'm going to use the value I took from this direction. So I'm going to use 9.33. So I'm going to use negative 1400 times 9.33 plus however far by is, which is the reaction we're going to have, by, we have ay here, no ax, there's no horizontal loading. So we got 14 by. So let's get our by value, 1400 times 9.33 divided by 14. So I'm getting a value for by of 933 kilonewtons. Let's box that. I'm gonna place it here, get rid of this. Let's clean up this place a little bit. At this point, we don't need this because we're not taking it about that point. I just wanted to show you guys how the location is equivalent no matter where you start. You just have to know where the centroid is from whatever origin point you're choosing. So now let's do this. Let's move this up a little bit and let's do the sum of the forces in the y directions to get the reaction A. Whoops, let me zoom back in. Sum of the forces in the y. Let's see, we got negative 1400 coming downward. We have plus 933 uh shooting upward from the By reaction plus whatever AY is equals 0. So now just simple algebra will give me a value of 467. So I got AY equals 467 kilonewtons. Now, you just want to use your units at all times. Always price your units because your professor, if you just give a value of 467 or 933, your professor's going to say, and he knows that, or he or she knows that it's going to be a value of force, right? But they just want to see that you're using your units consistently because then they're just going to say, well, 467 what? But we all know that we're working in the force kilonewtons here. So just write kilonewtons when you're giving your final answer. You kind of want to make a habit of that because when the problems get more complicated, you're going to lose track of your units. So let's see if these equal to the summation of forces. We got 467 plus 933. I'm getting 1400. So this beam is equivalently loaded at this point. All right, thanks for watching.